Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 62. Unique paths. So it says a robot is located at the top left corner of a m into n grid. Mark start in the diagram below. So over here you can see that there is a start and here is our robot. The robot can only move with the down or right at any point in time. The robot is trying to reach the bottom right corner of the grid marked finished in the diagram below. So this is where he wants to reach. So how many possible unique paths are there? So this robot who can move either right or down wants to reach this cell, which is at the bottom right corner of the grid, right? So what will happen is there are multiple paths that can come up in the process, right? Either he can go right, he can then come down, or he can continue to go right. So there are a lot of possible paths that's possible, right? In order to reach the grid. And we need to come up with the number of such possible paths. So as I always recommend, do give it a try yourself. This is a very basic level dynamic programming problem. So once you give a try, you can check out the video, you can continue watching the video, and in the meantime, let's head over to the board and check out the solution. So what we have done over here is we have taken the same example from the Leetcode, and we have placed our robot on the top left corner. But yeah, the robot doesn't look the same. We have our own robot and we want to reach the bottom right corner of the grid, right? As we know, the robot can either go right or he can go down. He cannot go up or he cannot go left, right? Keep that in mind. So if the robot has to reach here, there can be several paths. He can come all the way right and then all the way down, or he can come like this. There could be n number of ways he comes, right? As long as he's following this rule, there can be n number of ways he can get that done, right, to reach the destination. But we need to figure out how many paths are there. So how do we find it out? So what we are going to do is we are going to take every possible cell over here, like this, every possible rectangle we have in this. Like this is a rectangle, right? Even this is a rectangle, even this is a rectangle, even this is a rectangle. So we are going to solve all this sub problem. So this is a sub problem. If I have a grid of size 1 into 2, if I have a size grid 2 into 2, so I will be calculating for all. So let's try to see how we are going to do that. Let us pick a sub problem over here. Let's say we have only this to cell, right? And the robot is allowed to go right and he has to reach the destination. So how many ways can he reach it? So there is only one way. He has to go right. There is no other choice for him, right? So I can say that this number over here will be 1, right? There is only one way to reach this cell, because if he goes down, the up movement is not allowed. He cannot come here, right? So we can say that there is only one way the robot can reach this cell, right? Similarly, now forget this cell is not there. We have only these two. So how many ways the robot can reach the end? There is only one way. He has to go down. There is no other choice left for him. So the answer would be 1. So I know that if this is, so what does this cell tell me? That if this is the starting, if the robot is the top left and this is the bottom right, then how many ways the robot can reach over here? Same goes for this, right? We are solving for each of the sub problem. So this cell over here answer for this sub problem, and this cell over here answers for this sub problem, this box over here, right? So let's extend the boxes. So now we have extended the boxes, right? Now we have this sub problem over here. So this sub problem over here says that if the robot is at the top left and this is the bottom right, then what is my answer, right? And you can see that there are two cells which needs to be answered, and once we answer them, then only we can find out our final answer over here, right? So what I know for this cell, the robot can either come from top or from left, right? Because he's only allowed two movement, right and down. So there are two paths coming to him. So either he can come like this or he can come like this. So what if we sum these two? We will get our answer over here, right? So this will be nothing but 2. So if you check out the solution over here, so what happened basically is for all these cells over here, all these cells, right? There is only one way to reach this cell for the robot, because he cannot climb up. He can only go down. Similarly, for these cells also, what we know is that there is only one way, that is you have to go down. So the first row and the first column, we know the answer that there is only one way, since there is no left or up movement allowed. So there is only one way to reach them, right? And now for the other subsequent cell over here, so let me remove this. And also we know that this is going to be our destination, the end that we are looking for, right? So let me put that over here. say from this statement is we don't know the value for this. So we know only the value for the first row and the first column, which is going to be 1, right? So we have solved for all these subproblems. So if the cell is of this size, if this is the matrix, if this is the matrix, and similarly if this is the matrix, these first two cells, then first three cells, all that, right? And now we are going to solve the subproblem. And also we have seen a solution over here, that how we are getting the result for this one. We are just doing an addition, and which is telling us how many ways we can come to this cell, right? So if you see that what we are basically doing is we are encaching the two subproblem that we have previously solved. So if I take this cell over here, so you will see that we have three ways to come here, because we know there is two way to come to this cell, right? One is like this, the other is like this, and this cell over here can be reached from top as well, right? Somebody can come down from the top, so there is definitely one path from the top. So there is one way to reach the top, and that is going to help us. So these are the three paths. So one is this, the other is this, the other is this. At the end, when we are done filling up this table, we'll be having our answer over here in this cell, right? And each of the cell has their own answers, considering if the grid ends over there. Similarly for this, it will be 3 plus 1 4. Similarly for this, there is 4 plus 1 5. And you know the reason why, because we have already found out that there are three ways to reach over here, and there is one way to reach over here, and this cell over here can be reached from either top or from left, right? So it becomes a very logical conclusion how we are reaching to the result. Similarly over here also we'll keep on doing so. So we have 6, then 6 plus 1, we have 7 ways of reaching it. Similarly over here we have 3 ways of reaching it, and you know those 3 ways. So there are 2 ways of, there is one way of reaching it, there is one way of reaching it, so there are 2 ways to reach it, right? And there is one way to reach at the bottom, so we can approach from the left side as well. So I hope you got the concept of how we are finding it out. So 3 plus 3, we have 6 ways to reach it. 6 plus 4, we have 10 ways to reach it. 10 plus 5, we have 15 ways to reach it. 15 plus 6, we have 21 ways to reach it. And 21 plus 7, we have 28 ways to reach this cell over here. So if you check the answer over here, you will find that the output is 28. And we have seen how we are getting that 28, right? So why we call it dynamic programming? Because we are solving all the subproblems over here. So just imagine, instead of telling that this is your end, if somebody comes and tells you this is your end, this is where your robot should end. So you know there are 10 ways to reach it. So for every cell you know the answer, right? That's why we call it dynamic programming. So dynamic programming basically tells you that I am solving all the subproblems and I am expanding myself based on the prior calculation that I have made for the subproblem. So I am gathering results from the subproblem and I am forming the next results. And that's what we did. So for every cell, what we did is we did an addition of the top and addition of the left. And that is valid for all the cells if you check over here, right? We did for all the cells. So if I don't calculate this, I will never get this answer, right? So we should solve the smaller subproblem first and then try to build on top of it. So this is the solution all about, right? And we are going to put that into code and see how things goes. So before we start solving, one more thing, that as you see that this is nothing, the grid that we have got as an input, we got a m and a n, right? We are going to create a m by n integer matrix because these are the numbers, right? We are going to create two-dimensional array over here and we are going to call it paths and not dp. Okay, so we are going to create it with the size m and n as so m and n is the input given to us, and we'll have our result store in the bottom right cell of the array. So we are going to say that we'll have it at m minus 1 n minus 1 at index, right? Because that's the last index in a two-dimensional matrix, right? And now what we'll do is we are going to fill up the base cases. So what we know is that path 0, 0, that is where the robot is, that the answer should be 0 over here because the robot is already there and there is no need for any additional paths, right? And what else we are going to do is we are going to iterate over this array that we have created, and we know the base cases, right? If you remember over here that these two, the first row and the first column is our base case, right? So we are going to fill that up, and once we fill that up, we know how we should be taking care of the other things. So path I0 will be initializing with 1, right? And same goes for the column. So we'll do the same thing for the column as well. So here we are done with the row and the column. Since m and n could vary, so we cannot use a single loop. If it is square, then we could have used a single loop over here. Though you can still do a single loop, finding the max and then checking the length. I thought of not doing it. It's better to get it done in two different loops, right? So here your complexity would be order of n plus order of n. And now what we are going to do is we are going to have a loop, nested loop, and which is going to contribute to our actual complexity, which is order of mn, right? Because we have to traverse the entire grid that we have created. So I less than m. So basically, instead of starting from 0, what we can do is we can start from 1, because we know for the 0th row and 0th column we have already taken care of it, right? So we will basically start from 1 1. So let's take j to 1 as well, and j less than n. And what we are going to do over here is path ij. So what we are going to do over here is to put the path ij equals to the top cell and the left cell, right? So what does that mean? We have to go one row up. So we'll be basically doing a I minus 1 and remain at the same row, right? So paths I minus 1 j, and for the other one, what will happen is I will remain at the same and j will be decremented by 1. That is, we are moving one row to the left, right? And this is how we are doing the calculation. And that's what we did in our example as well over here, right? If you remember, right? We have been doing for adding these two up for this cell over here, right? So yeah, this is the solution all about. So let's submit and check. I have to make some mistakes. Otherwise, it doesn't work out for me. So yeah, it's been accepted. We have output 28 that we are looking for. Let's do a submit and check for a broader range of test cases. Pretty cool. We have a submission faster than 100% of all the submission, which took 0 milliseconds of time. And of course, we are creating m into n space, so it costed us 35 MB for all the test cases over here. So again, looking at this problem statement over here, what you can say is that we have a space complexity of m into n. So this is applicable for both your runtime and space as well, because we are iterating over this array as well, right? Completely. So this is so this order of mn. So this will basically come to order of mn, and this is applicable for both your runtime and space, right? So both will have this. So yeah, this is the solution all about. Do let me know what you think about the solution. If you have any questions or doubts, post it in the comment section below. So this is a very basic level dynamic problem, and I hope you got the concept. The concept is very easy, very straightforward. So once again, I would like to reiterate that for dynamic programming problem, there is nothing to memorize. We just have given a name called dynamic programming, but it's very logical. And also earlier in the video, I think, given some insight what dynamic programming is all about, right? It's not about memorizing some patterns or understand that we have to create a table or something like that. So it is important for you to understand why we need the table in the first place, right? And what is the table going to do? So it is not about any patterns that we have to go one row down, one row up, one row left. It has to be something logical, and I hope you got the logic of each and every cell that we have discussed over here. So it would be good to hear back from you guys. Do let me know. So yeah, that's all from this video. Do like and subscribe. Do share with your friends. So if you're a new viewer, do like and subscribe to the channel. I try to create videos every day on Leetcode or some other problems. And shortly, I am planning to start some other topics, some generic topics wherein we'll be discussing data structure and algorithm the way we discuss Leetcode in much more details. So yeah, that's all from this video. Hope to see you guys soon. Stay safe and stay at home and practice a lot. It will be helpful. Bye bye.